Hi Senior 1 students. Today I'll revise the most important laws in our syllabus. And to calculate the number of moles of any substance, we have 5 laws. The first law, mass of a substance over molar mass. The second law is number of particles over Avogadro's number, which is equal 6.02 times 10 to the power 23. The third law, volume of a gas at STP over 22.4. The fourth law, molarity times volume of solution in liter. And the fifth one is molality times mass of solvent in kilogram. Also, you can calculate the other physical quantities by using the opposite mathematical relations, as we will see in the following problems. Let's answer the following questions. Question number 1, calculate number of moles of 53 gram of sodium carbonate, knowing that atomic masses of sodium 23, hydrogen 1, carbon 12, and oxygen 16. The chemical formula of sodium carbonate is Na2CO3. As you see, the mass of sodium carbonate is given in this problem. Then we can calculate number of moles of sodium carbonate by dividing its mass, 53 gram, by its molar mass. Molar mass of sodium carbonate can be calculated by adding atomic masses of its elements. 2 times 23 plus 12 plus 3 times 16. The result will be 2 moles. Number 2, calculate number of atoms in 1 mole of water. You must differentiate between number of atoms of water in a molecule and number of atoms in 1 mole. Because water as a molecule consists of 3 atoms, 2 hydrogen atoms and 1 oxygen atom, but number of atoms in 1 mole of water will be 3 times Avogadro's number. The result will be 18.06 times 10 to the power 23 atoms. Number 3, calculate number of molecules in 88 gram of carbon dioxide. To calculate number of molecules of carbon dioxide, we must calculate number of its moles by dividing its mass, 88 gram, by its molar mass, which is calculated to be 44 gram. Then multiply number of moles of carbon dioxide by Avogadro's number. 2 times 6.02 times 10 to the power 23. The result will be 12.04 times 10 to the power 23. Number 4, calculate number of produced sodium ions from dissolving 53 gram of sodium carbonate. In this problem, you must write the equation of dissolving sodium carbonate in water into 2 moles of sodium ions and 1 mole of carbonate ion. And I'll focus on sodium carbonate and its ions. As you see in this balanced equation, 1 mole of sodium carbonate produces 2 moles of sodium ions. And to know number of moles of sodium ions, we will calculate number of moles of sodium carbonate by dividing its mass, 53, by its molar mass. Then calculate number of moles of sodium ions by using scissors way. It will be 1 mole. And to calculate number of sodium ions, multiply number of moles by Avogadro's number. Then the result will be 6.02 times 10 to the power 23 ions. Number 6, calculate number of atoms. Number 5, calculate number of carbon atoms found in 50 gram of calcium carbonate. Number 5 nearly similar to number 5. We will focus on calcium carbonate and carbon only. 1 mole of calcium carbonate consists of 1 mole of carbon atoms. To know number of moles of carbon atoms, calculate number of moles of calcium carbonate by dividing its mass 50 gram by its molar mass 40 plus 12 plus 3 times 16. Then number of moles of carbon atoms will be half mole. Now you can calculate number of carbon atoms by applying the following law. Number of moles of carbon atoms times Avogadro's number. The result will be 3.01 times 10 to the power 23 atoms. Number 6, calculate number of atoms found in half mole of formaldehyde HCHO. 1 molecule of HCHO consists of 4 atoms, 2 hydrogen atoms, 1 carbon atom, and 1 oxygen atom. Then 1 mole of HCHO consists of 4 moles times Avogadro's number. But what about half mole of HCHO? By using scissors way, it will be 12.04 times 10 to the power 23. Calculate the mass of 0.2 mole of calcium hydroxide. Calculate the mass of 3 times 10 to the power 22 carbon atoms, and calculate the mass of 22.4 liter of nitrogen gas at STP. To calculate the mass in 3 problems, the main idea to solve this type of problems is finding number of moles. In number 1, number of moles is already found. Then we can calculate the mass directly by multiplying number of moles 0.2 by molar mass of calcium hydroxide. The result will be 14.8 gram. In number 2, number of moles can be calculated by dividing number of atoms 3 times 10 to the power 22 by Avogadro's number, which is 6.02 times 10 to the power 23. Then multiply number of moles of carbon, which is 0.05, by molar mass of carbon, which is 12. The result will be 0.6 gram. And in number 3, number of moles can be calculated by dividing volume of a gas, which is nitrogen gas at STP, by 22.4. Then multiply number of moles of nitrogen by its molar mass. The result will be 28 gram. Question number 3. A human hair that is 60 micrometer in diameter is what times larger than a DNA molecule that is 2 nanometer in diameter? Micrometer as a measuring unit for length is larger than nanometer by 1,000 times. Then 60 micrometer equals 60,000 nanometer. And to find the relation between the diameter of human hair and the diameter of DNA molecule, divide 60,000 by 2. The result will be 30,000. Choice C. A chemical compound contains 40% of element A and 12% of element B, knowing that atomic masses of A 40, B 12, C 16. What is the molecular formula of this compound? You must know that the sum of the percentages of elements forming the compound must be equal to 100. We find that the percentage of element A 40%, plus percentage of element B 12%. The sum of A and B percentage will be equal to 52%. Therefore, there is a third element to complete 100%. We will assume its symbol to be C, and its percentage will be 100 minus between brackets 40 plus 12 equals 48%. Now we can find the molecular formula by calculating number of moles of each element A, B, then C, and then find ratio between them. It will be 1, 2, 1, 2, 3. Then its molecular formula, also its empirical formula, will be A, B, C, 3. Choice A. If 5 grams of each reactant were used for the following process, knowing that atomic masses of hydrogen, oxygen, chlorine, potassium, manganese, and mercury determine the limiting reactant. To determine the limiting reactant, we must choose all reactants with only one product from these products. I'll choose potassium chloride, KCl, as a product, and you can choose any another one of products. Here we have 3 reactants, KMNO4, Hg2Cl2, and HCl, and we want to know which one of them is limiting reactant. First, we must calculate number of moles of the produced KCl from each reactant as follows. Two moles of KMNO4 produces 2 moles of KCl, and by dividing mass of KMNO4 5 gram by its molar mass, the result will be 0.05 mole. By using scissors way, number of moles of potassium chloride as a product equals 0.05 mole. In the same manner, we will calculate number of moles of KCl as a product produced from Hg2Cl2 as a reactant, also from HCl as a reactant. Finally, we will find that Hg2Cl2 is the limiting reactant because it produced the least number of moles of KCl as a product. Find the volume of 12.04 times 10 to the power 23 molecules of oxygen gas at STP. Also find the volume of 56 grams of nitrogen gas at STP. To calculate the volume of any gas at STP, we must follow 2 steps. The first step, calculate number of moles of oxygen gas by dividing number of molecules by Avogadro's number. It will be 2 moles. And in the second step, calculate the volume of oxygen gas at STP by applying Avogadro's law, by multiplying number of moles of oxygen, which equals 2 by 22.4. The result will be 44.8 liter. You can apply the same idea on problem number 2 to calculate the volume of nitrogen gas at STP. If 2 moles of nitrogen gas react with an excess amount of hydrogen gas at STP according to the following equation, calculate the produced volume of ammonia. 1 mole of nitrogen gas reacts with 3 moles of hydrogen gas to produce 2 moles of ammonia gas. Therefore, I'll focus on nitrogen gas and ammonia gas. 1 mole of nitrogen produces 2 moles of ammonia, but 2 moles of nitrogen produces what number of moles of ammonia? By using scissors way, number of moles of ammonia will be 4 moles. Then apply Avogadro's law to calculate the produced volume of ammonia. The result will be 89.6 liter. Number 7. What is the mass of potassium hydroxide required to prepare 500 ml of 2 mole per liter of this solution? In this problem, we want to calculate the mass of potassium hydroxide. Its chemical formula is KOH. Its volume is 500 and its molarity is 2 mole per liter. But the volume in this problem must be in liter. So we will divide 500 milli by 1000 to be 0.5 liter. Then calculate the molar mass of potassium hydroxide to be 56 gram. Finally, apply the following law: molarity times molar mass times volume of solution in liter. Then the mass will be 56 gram. Calculate the molality of a prepared solution by dissolving 20 gram of sodium hydroxide in 800 gram of water. When you calculate the molality of any solution, you must differentiate between measuring unit of mass of solute and mass of solvent, because mass of solvent like water must be in kilogram. So the mass of water, 800 gram, will be divided by 1000 to be 0.8 kilogram. Then calculate number of moles of NaOH by dividing its mass, 20 gram, by its molar mass. Finally, apply the law of molality by dividing number of moles of NaOH by mass of water as a solvent in kilogram equals 0.5 over 0.8, and the result will be 0.625 mole per kilogram. Thank you for listening and goodbye.